Chandrayaan mission. Chandrayaan-1. Chandrayaan-1 was India's first lunar mission, launched on October 22, 2008. Chandrayaan-1's impact. Chandrayaan-1 made significant discoveries during its mission. The Moon Impact Probe, MIP, released by the spacecraft made a controlled impact on the lunar surface near the Shackleton crater, confirming the presence of water molecules in the form of hydroxyl ions, O, in the lunar soil. Imaging and mapping. The Chandrayaan-1 mission provided detailed images and high-resolution maps of the lunar surface. It captured and transmitted images using its Terrain Mapping Camera, TMC, and the Lunar Reconnaissance Orbiter Camera, LROC, provided by NASA. Moon Mineralogy Mapper, M3. Chandrayaan-1 carried an instrument called the Moon Mineralogy Mapper, M3, provided by NASA. M3 created a spectral map of the lunar surface, revealing the presence of various minerals, including pyroxenes, olivine, and water-bearing minerals. Search for water. One of the primary objectives of the Chandrayaan missions is to search for water on the Moon. The discovery of water molecules in the lunar soil by Chandrayaan-1 was a significant achievement. Chandrayaan-2 aimed to further investigate the presence and distribution of water ice in the lunar polar regions. GSLV launch vehicle. Both Chandrayaan-1 and Chandrayaan-2 were launched using the Geosynchronous Satellite Launch Vehicle, GSLV. GSLV is an expendable launch system developed by ISRO specifically designed to launch heavier payloads into geostationary transfer orbits and beyond. Instruments on Chandrayaan-2. The Chandrayaan-2 mission carried several scientific instruments on board the orbiter, lander, and rover. Some notable instruments include the Large Area Soft X-ray Spectrometer, class, for mapping major rock-forming elements, the Dual Frequency Synthetic Aperture Radar, DFSAR, for studying the subsurface structure, and the Alpha Particle X-ray Spectrometer, APXS, for elemental analysis. Lunar South Pole landing. The Chandrayaan-2 mission aimed to achieve a soft landing near the lunar South Pole. The South Pole region is of particular interest due to the presence of permanently shadowed regions that could potentially contain water ice. Unfortunately, because of a software glitch, the craft lost all communications just minutes before it was supposed to land. It deviated from its intended trajectory and crashed. Though it was not a complete failure, the orbiter is still functional and provides valuable data to the organization. Chandrayaan-3 is the next mission after Chandrayaan-2, which aims to land safely and explore the Moon's surface. It consists of a lander and rover that will be launched into space by a rocket called LVM-3 from SDSC Shar, Sriharikota. The GSLV Mark III Heavy Lift Launch Vehicle, also known as the Bahubali rocket, will support the Moon lander Vikram. The GSLV, now known as Launch Vehicle Mark III, LM-3, is 43.5 meters tall. The spacecraft is scheduled to touch down on the Moon on August 23 after a voyage that will last more than 40 days. Chandrayaan-3 launched at 2:35 p.m. IST on July 14, 2023, from the Satish Dhawan Space Center in Sriharikota, Andhra Pradesh. The spacecraft was launched by the Launch Vehicle Mark III, LVM-3, and carries a lander and a rover. After landing on the surface in August, the rover will then deploy and explore the lunar surface. The craft is set to land on the south pole of the Moon, where Chandrayaan-1 discovered the presence of water molecules. The craft collectively weighs 3,900 kg. The propulsion module weighs 2,148 kg, and the lander and the rover weigh 1,752 kg. This total weight is close to the maximum capacity of the GSLV Mk3, which is India's strongest rocket. Once in space, the orbiter will carry Vikram towards the Moon. It will orbit the Moon and gradually adjust its path to enter a circular polar orbit 100 km above the Moon's surface. Once Chandrayaan-3 safely lands on the Moon, the Pragyan rover will be deployed to explore. The rover will be released from Vikram using a ramp. This six-wheeled rover is powered by solar energy and carries two spectrometers to study the composition of the Moon's surface. It will move around the landing area for about 14 Earth days, which is roughly equivalent to one lunar day of sunlight. Vikram lander is equipped with 4 scientific instruments as well. The first instrument is a seismometer designed to detect moonquakes, while the second one studies how heat moves through the lunar surface. The third aims to understand the plasma environment around the Moon, and the fourth is a retroreflector to help understand the gravitational interaction between the Moon and the planet. According to NASA, the USSR, the US, China, and Israel are the only nations in the world to have attempted to land on the Moon. The USSR has had 12 unsuccessful attempts, however, it has succeeded twice. Out of 8 landing missions, the US has succeeded in 5 of them. China has attempted 2 landing missions so far, and both of them were successful. Israel's first and only attempt failed. India's previous 2 lunar missions are counted as orbiters and not landing missions.